And then the next page is going to be our network plan. This one is of West Michigan Uniform. So this is the network plan that we will see, and it's just the standalone Transline. Okay. When we do the economies and the novos and we do a combined network plan, that's the one that's promulgated. And once again, the IP addresses we were talking about was 10.8 what? 2 and what else? 15. So 10.8 2, we can see here. Oh, let me blow that up. So there you go. K1, 10.8.2.12, the CTT 10.8.2.2, and then the database 10.8.2.20. Forever and always. Those don't change. Those are hard how they are. The first XMT will always be a 21. The first IBT for the XMT will be a 22. And then now finally we get into the circuit diagrams. Who was it? Okay. Stefan asked us, William, you keep saying to have a customer, give us a designation of a 5.2.1 or a 15.1.1. Where do I get that from? Okay. In W2, we over label. See these boxes, label, 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 label. We label every single sensor, cylinder, conveyor, motor coupling module, inverter. We label it, and it doesn't come pre-labeled. This is a little bit of work, but we go through and do pages and pages and pages of labels.
Are you saying it's label intensive?
Very label intensive.
Let's see what you did.
So the customer calls, he gives you a conveyor number. Woohoo! Great. Now what? Okay. Down in the table of contents in the equipment manual, normally what? It'll be like plus M page 1, plus M page 2, plus M page 3 in the equipment manual. Machine page 1, machine page 2, machine page 3. For the Transline, what we actually use is the conveyor number. So we will start off at the lowest number. This is for 0.1.1. And we'll do the pages for it. Then we will go to the next conveyor. It could be 5.1.1. And we'll list its pages. Then we'll do conveyor 6. Then conveyor 15. And we'll go in numerical order from lowest to the highest. That's how you navigate finding these things. So TLP 15.1.1, ding ding, there it is. Right there. The parts, the electrical parts manual follows the same suit. Okay, it starts off with the lowest number, it'll go through its components. And then it'll go to the next conveyor and go through all its components. And we're going to see that later on.
Two schematics kept in where all the other schematics kept, like for the equipment and all.
No.
Where are these kept in?
Oxford. So.
William. 1-800 William.
Okay. So. Quick history, Oxford was on a different system than HKV and Starstad and Hoya and all the other ones, blah, 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 whatever. And they never got Oxford onto the correct system to get them to be able to implement everything up to my Carnegie. Okay. For some of the new systems, okay? Some of them have gotten on to my Conagies or somehow, but a lot of them are not the complete. So it may be just the parts manual, it may be just the parts manual and the electronic section or something like that. Paul, have you come across one that had everything yet?
I think Noble Miami had it.
Okay,
They had like 4 or 5 folders in there.
Okay.
It's pretty complete.
so from here on, I think we've gotten better to where documentation will be readily accessible. For our older systems, no.
So if we're on the job site and you look at schematics, we just turn around and call the rail guys and say, hey, take over.
So, now. So, where did we put those? Did those all end up on Minneapolis? The W2 manual. Remember, we did that about 2 years
I
ago,
think it's
the Hey William.
It was in the Minneapolis job archive files. if I'm not mistaken.
Okay, so if you have access to the Minneapolis drive, we have been backfilling a bunch of them to there. If you have access to the Grand Prairie drive, you probably got from like 2015, 16 back manuals accessible there. Okay? The whole key point with this is if you understand one conveyor, you can probably troubleshoot 90% of the W2 systems. A conveyor is a conveyor is a conveyor. Okay, we bring stuff in, we kick stuff out. You just have to understand the process and the concept, right? It's no different than Jacob if he goes over there and the guy says, I got a problem with an iron rod. He doesn't care if it's a small piece. Peter, he doesn't care if it's a sheet. It's the same process, okay? He can get through it. He doesn't need to know it inside and out, okay? For all conveyors, what are we doing? This is, if you see, most of our schematics will have a direction of flow of the hangers. That's what the arrow is for. So this is showing hangers are coming in from the left, going to the right. So over here, we had another conveyor and it transferred. Whenever we transfer, we are always monitoring that transfer. We got to have something that says nothing is blocking the area between the two conveyors. So we're monitoring that. Don't worry about what kind of sensor it is. There is some sensor there monitoring. Okay. They can look up the part to see whether it's a 12mm sensor, whether it's a laser sensor, whether it's a big 90mm, whether it's a whisker switch, it's irrelevant. There's a sensor there monitoring the transfer. Next thing we have common on all conveyors, we're going to have a full. We have to be able to know that if we get hangers backing all the way up to here, we need to tell the conveyor over here, stop, don't send anymore. I'm full. So we always monitor and we're always going to have a full switch. The other thing that we're going to have is we're going to have some type of stopping mechanism to prevent hangers from going forward, right? If this area over here says, hey, I'm full, don't send anymore. Well, I'm not going to stop my conveyor. Starting and stopping of motors undo wear. Okay, you get voltage surges. We just keep them running. Keep them running. We throw up a stopper, everything backs up, clears out down the road, drop the stopper, and everything can index out. Okay. Here's the so here's an MKM box showing you power coming in and everything. All right, so we're going to go through this one in a little bit of detail just to kind of give you some visualization. So we're going to look at B1 in this pictorial symbology represents a rocker switch. So this is showing us this B1 is this type of sensor. Item comes through, raises the rocker up, and the green proximity sensor over here is made.
So just for clarification, that your flow of goods is going to the right
Yes,
in this diagram from the right. That's.
from the left to the right, because
Sorry, yes, from the left to the right.
this
That
would
set-
be
that set-
the other way. Yes, it would be inverted with the flow of the arc.
Okay,
Correct.
just so that.
You passed. That was a test. Good job. Okay. B2, the full sensor is going to be this 90 mil sensor that's over here. The B3, 4, and 5, those are a whisker type switch. And then the Q6, the stopper, it's right here. So they got a little button that pops up and the hangers can't flow, and then they build up the buffer in that area.
Are bees always?
These are always
Sensors.
going to be sensors. Qs are going to be your solenoid. Qs are also contactors. S's are, yeah, switches. P's are lights. Those are the most common ones, I think. Right, Meshley? Think anything else up there? And motor.
And that's W is usually a cable, like WM.
Yes. All right, any questions over that? So, in this case, if B5 was bad, I would go ahead and go down my table of contents. You see, this is an 82. Now I start in 15s and I go down B2, 3, 4, 5. Here's 115, B5. There's my part number. Shows me it's a full indication. The other uniqueness of the W2 system is we know we've got these X67 modules labeled all the way around. The X67 modules match the conveyor number. So the first X67 module for conveyor 115 is going to be labeled 115 2 TAC 1 KO. Okay, Ks are going to be your X67 modules. The other good thing about the W2 system is B1 is plugged into input 1 of that module. B3 is plugged into 3.
Wait a second, that makes too much sense.
Guess Q6. Where do you think Q6 is? Where are we looking for light to light? Number 6, on and off. You don't necessarily need the manual if you understand the concept of the numbering and you understand the process of one conveyor.
So there won't be a B1 and a Q1.
Nope, never.
67.
What we do is we start off with K0 and we go 1 through 8. Okay, and then if we have more modules on there, what we actually do is go to a K 0.1 and we start the numbering off at 21, 22 to 28. And then if we need another one, then we start the numbering off. It would be B31 through Q38. And then you got Q0, you've got a 0.1, a 0.2, a 0.3, a 0.4, a 0.5 for the additional modules if you did have a ton of sensors on that conveyor.
You're never gonna have a 9.
Never have a 9. Never have a 0.